Welcome to episode 57 of the Brainstorm. We've got Frank back on to talk about none other than AI again. But I say that because so much is happening so quickly. This time, Sakana. Is that the right pronunciation, Frank?
Yep, you got it.
All right, Sakana, $15, and we're getting academic papers. Is that what? We'll dive into the details here. What makes this so novel?
Okay, so to set the stage, this is basically a project being unveiled by an AI research lab in Japan called Sakana AI. It's a team of ex-Google Brain employees that essentially set out with this goal of automating the scientific method or the research process. So how can we take what LLMs are good at, digesting information, potentially planning and running experiments and channel it kind of towards new scientific discovery? It's been something that's been a dream in the research or AI space generally for a long time. So it's not a new concept, but we're just kind of now starting to have the right bits and pieces to put these types of workflows together. And what the team has basically done is create a system. So it's a model plus kind of like a framework in which it operates, where you can give it a research idea, like find ways to train large language models more efficiently. And it will go brainstorm ideas, make sure they're novel ideas and haven't already been discovered or researched, write the code needed to build an experiment and test that experiment, and then write it all up in a nice kind of more traditional, academic paper format. And it's giving pretty good results. So they've created a grading mechanism that suggests that these papers could be admissible to a machine learning conference. They haven't gone through a full peer review process. We're not saying that these are necessarily going to lead to massive new breakthroughs tomorrow, but at the current state, it's essentially a tool that, scientific researchers can use to accelerate their process and potentially generate new ideas.
Are there any limitations to the type of research it can conduct?
Like any large language model enabled project, it's probably going to be better at things that it was trained on. So models that have no math data aren't going to be good at let's say researching math theory. But in theory, you can give this thing anything, and your mileage may vary depending on what's output. Like it's hard to say at this point. And there's very simple things that the system's not good at yet that I would expect to be solved pretty quickly. Like it's not very good at comparing the order of magnitude of numbers, which is a very known LLM problem that's quickly being solved. It also seems like this is more fundamental than that. That seems like a smaller issue that can be solved, but it can push an existing idea forward. Like, how can I train a transformer model more efficiently? But it might not be good enough yet to say, come up with an entirely new framework that's different from transformers that's going to be foundational for the next 10 years of AI. That seems like it's still a ways away in terms of capabilities.
Could you, in theory, with the orders of magnitude issue with numbers, could you have this research agent conduct an experiment on how to make itself better so that it doesn't have this problem?
Yes. And that's kind of like the cool thing about it is when you kind of can distill the research and discovery process down to just giving a task to a computer to go execute, you can all of a sudden iterate through these types of problems much more quickly. And then the other very simple way to fix that is just tweak it so that whenever it's comparing numbers, it writes code to do that instead of relying on the model's intrinsic capabilities to do it. So you can solve the problem by kind of fundamentally changing the way the LLM works, or giving the model its own workaround, because that's when we talk about kind of agentic systems, which is quickly becoming the new AI buzzword, it's not what you're used to with ChatGPT, where you just ask it one question and it gives you one answer, kind of start to finish in one shot. The whole idea is that you're giving a model a series of tools that it can use and an iterative process by which to use it. So it will look at the tools available, use them to answer a question or a step in a process, and then iterate on that. So it could quickly see, oh, am I comparing two numbers? Self-reflexive. Okay, I'm going to use code to do that instead of my, let's say, mental math.
So it's almost like an aftermarket add-on to make existing LLMs much more capable.
Yes. Andrew Ng, who we had on the podcast recently, talks about building a coding agent, and you can actually get relative to GPT-4, which is one of the best coding models, versus GPT 3.5, the model that came before it, the old model, not very good at coding. You can slap an aftermarket agentic framework on top of GPT 3.5, this kind of planning and iterative approach, and all of a sudden it's better than GPT-4. So that's exactly what it is. It's basically like an aftermarket upgrade. Though it's expected OpenAI, Anthropic, they're all working on their own internal agentic capabilities, so they can be bringing these instead of kind of the open source and research community.
All right, Nick, you go, and then I'm
yeah, no, I mean, just going back to the research capability, I mean, is the idea that you're essentially handing a super intelligent entity the framework of the scientific method and then just saying, go out and run as many experiments as possible until you find the optimized, solution. Is there like an analogy in the real world of like, it would be the equivalent of putting 1 million plus human hours to a specific research task in a short amount of time?
Well, we were talking about this in Brainstorm itself, and I actually still remember. There's a quote from a freshman year professor I had, and he said, if you want to make a discovery, take something blatantly obvious in one field and apply it to another field. And it's like, that's potentially where something like this has the ability to really shine, because I feel like academics and academia, you wind up so in the weeds focused on your specific area that if you have this LLM that's trained on such a huge breadth of information, it has, in theory, the potential to take those things that are taken advantage or taken for granted in one field and see if they can be applied to another.
Yes, I think that's a great example of a use case of, why hasn't anybody done this in that field yet? And it's because they didn't have the time or the incentives. But now when it only costs $15 to create a paper to go explore a new idea applied to an old idea applied to a new field, the barrier to entry to doing that is much lower. To give a sense of like superhuman time saving, to Nick's point, Amazon has a coding agent. So it's an agentic framework built specifically for coding, called Q, and they're using that internally. And they said in their most recent earnings call that they've saved 4,500 developer years using this. So, and over $260 million. And they've used it to modernize 30,000 internal Java applications. So it is taking what would be a lengthy human process and reducing it down to identify the problems you want to go get solved, spin up some NVIDIA servers, and press run. And it does it.
That's right. That's until you connect it to the Optimus bots who can start micro pipetting things, and then you get your fully automated lab.
Yeah, and the other thing is like about running them in a loop or for a long period of time is compounding discoveries. So that's what I think is interesting with like the sample question of like find a way to train LLMs for a lower cost. Well, you do that with today's model, and you train a model that's better at a lower cost tomorrow. And then you just keep doing that, and you keep getting better and better and more cost-effective systems. So the AI, it becomes basically the system training itself. So that's what some people believe is kind of like the takeoff path to superhuman capabilities, which we're probably on the research side, we're probably not even at average human level yet. But it's, getting there. And every time a foundation model comes out from OpenAI or Anthropic, this type of system gets better. So it kind of inherits the advances in the base models.
So then let's use that to jump to this next topic. Unless, Nick, did you have a...
I have, well, this might just take us down a complete rabbit hole, but...
Go for it. Let's go.
Yeah, okay, let's do it. I feel like we've spent time in Brainstorm and just in chats, Frank, talking about, the focus on coding and how a lot of companies are, going after that market with large language models. Where do you think this leads to? As in, do you think people are still coding in the same way 5 years from now, even 1 year? Or is this like we're headed towards a no-code future and you can get pretty much anything you want from a simple text prompt?
I think the way I'd frame it is like we've had a long history of higher levels of abstraction in everything, but in coding specifically, it was like, one, punch cards. Then we're like, we've digitized things and we're coding in assembly language, which is the really low level machine code. And then we get to kind of C, which is better, but still kind of clunky, to Python, which is, and you'll use different things depending on your performance requirements, but a higher level of abstraction. LLMs are almost like the ultimate abstraction layer, where now you don't even need to know computer language at all. You speak human language and you get code as an output, or code as an intermediate layer that you don't even know code is being written. So that's what I think like business users are going to experience, where they're going to ask let's say whatever assistant is plugged into Salesforce today. They're going to say, tell me about the, sales in this region over the last month for this product line. And some LLM is going to go write some SQL code and pull from the right database and then create a pretty chart. The business user just sees they asked a question, they got a pretty chart with a thorough analysis. They don't even see that custom code was written to answer their question. So I think there's going to be a lot of use cases like that. And then for more like professional developers, that's an example of somebody who doesn't write code today that will be using code in the future and not knowing it. The life of a professional developer today, I think you're kind of heading towards a 10x software engineer, where maybe they're still writing some code, maybe they're doing higher level architecture design for whatever system's being created, but they're enabled so much for AI that the marginal cost to create custom software is collapsing dramatically. So I think with reduction in cost, you will get a lot more of custom application development that potentially could benefit app development platforms and put kind of traditional package single-use SaaS apps at risk.
Interesting.
It kind of goes back to the infinite interns are like one fully productive human. Not to say that interns aren't humans, but I think it also gets to another thing that I always think about is people think of computer language and English or natural language as separate things. But once you get to that level of abstraction, Frank, I think of it more like English, where everyone in our office speaks English. Or I'd say like in the professional US world, almost everyone speaks English. But it's like who's actually like masterful with English is very different, right? Who's out there writing the most compelling pieces that are forming the thoughts and shaping the world. I think there's two levels of.
Wouldn't they then be the best coders, developers in the future?
Maybe.
I think if you have mastered English, then you have a better ability to communicate what you actually want to see developed for you from an LLM. So maybe we should all be studying how to better communicate with one another, and that will ultimately help you better communicate with AI. Instead of, going to school for computer science, maybe you go become an English major.
Everyone should read the classics. It's full circle, full circle. Okay, but to semi-jump here to AI performance, right? Sakana, aftermarket, makes existing LLMs way better. We continue to see there's the rumors of, is it Strawberry and agentic AI, everything getting better and better, benchmarks, some being saturated, others being gamed, constant improvement. But it's like, does any of this matter? Like when we get something great, won't we know it?
It's
like all of this discussion is like, oh, it's getting so much better. Look at these benchmarks. It's like all of that seems exciting now in the moment, but it's only because we haven't actually hit the killer app.
Yeah, on benchmarks, I mean, all that matters at the end of the day is how something is applied in an end use case for an enterprise or a consumer, and that's what they're going to judge it on. Like, if I'm comparing the ChatGPT app versus Perplexity, I want to know which one's answering my question faster and more accurately. I don't care which model is better at MMLU, multi-language understanding, benchmark XYZ, right? So it's applied in use case, which, because the use cases for LLMs are so diverse, there's no single use case, right? It's hard to pick that single way to measure efficacy, which is why you see all these different benchmarking approaches. I actually that's why the leaderboard that's purely, I think it's like an ELO ranking leaderboard where people just rate which output they like better is kind of a good generalized one because you'll be able to see comparatively. But there's no like magic line where it's once we get to this score, we'll be able to automate all of scientific research. And I think that will take a lot more time and iteration. And it's becoming, I think, more and more as the narrative from kind of this agentic conversation that we just had, not just about the base model and the capabilities, but everything you're building around it, like what data you're connecting it to, what tools you're giving it to use, how big is your budget, and what do you want to actually go point it to and solve, that we're still pretty early in the life cycle for. Like we don't have an assistant today we can go have do what we'd have a first year analyst or associate do. We have very narrow kind of chat apps, basically.
It's almost back to your first point. It's like once you can reach that level of abstraction, then you know you've made it, right? It's like, Nick's gonna laugh at me, but Wise Polymarket talks about, it's like, it's the first application where people don't realize that it's,
gambling,
crypto underneath, right? It's like, oh, it's not a crypto success. It's a success because people like to use it. And I think go ahead.
Yeah, no, I think there's another spin on this too, because we're constantly hearing about benchmark improvement, and then you get your hands on these tools and services, and it doesn't feel like a drastic improvement. And I think it's partially just because, at least in my opinion, a chat interface is like a uniquely horrible way to use these services.
Maybe because you're not a master of English.
That could very well be it. But I think it's more so because it leaves it basically hangs the user out to dry, as in you go there and you have to be creative enough to come up with something to ask this chatbot. Like the intent to go there is quite, it's hard. And I think what will happen is you're going to have models begin to segment the market. And I think we're heading towards not a one model solves all, but many models solving many different things. Like I think I use Perplexity now more than ChatGPT because I go there with the intent to search. Whereas ChatGPT, you go there with the intent of, I'll play around with this and see if it's good at what I think I need it for, and then you kind of spend 10 minutes reconfiguring it, and then you're like, this was maybe a waste of time. Whereas like I think what they're doing, which is smart, is creating an app store. So you click into an app and you know exactly what you're going to ask it for. When you're just handed a blank page, how many people are going to be Picasso? No, not many, right? Like most people are just going to draw doodles. And I think that's like analogous to when you have like a chat bar and you're like, this thing can do everything. And then you go and ask and it's like, not that good. And you're like, okay, I'm just not going to do this again.
Nick, I actually think that's a great point. And it's like, I think you see that too with like, what was it, Suno and the music app? It's like, it creates amazing music, but most people don't know even what to ask for. And so it's like, oh, this is fun, I can do this. And then it kind of stops. I think the empty canvas, the empty page is incredibly intimidating to most people. And that's right. It's like writer's block. You just got to start writing.
Well, I think it's like, it's not a surprise to OpenAI or Perplexity that people need a little help, which is why they have like suggested prompts when you go to ask a question. Like Perplexity has follow-up questions, which is like a unique thing that didn't exist in traditional search that now you can do, that actually allows you to have like a one-click back and forth with the model instead of having to like think of a follow-up question, or maybe you wouldn't have even asked one, but now you get some additional insight because of those. Same with how you can create custom GPTs that are basically like a ChatGPT themed for a specific context. So like they have an ERA, AIERA GPT that allows you to ask questions of earnings calls. And it has, it can pull data from all the earnings call transcripts, and having all these different little, or like the chef ones, for example, or the travel planners, like they give somebody a kind of an intent that they can then follow on, that I think is helpful at this current stage of, like, to Nick's point, just blank text box is kind of a hard starting point. And I actually think it's kind of, it's very early and we haven't seen how these systems work in practice, but I think people have really skipped over what Google and Microsoft are doing with adding agents into their collaboration platforms. So I forget what they call it respectively, but Google Workspace, for example, in your team group chat, you can basically create an AI agent that's just sitting there meant to be helpful. And so if somebody in the group chat asks a question, like I'll just use like an ARC example. When was the last time we met with Coinbase and what are the meeting notes? And normally I would answer it or Nick would answer it. If the agent knows the answer, it's listening to the chat, it just pops in and becomes helpful. So when you have this kind of like passive agent that can be helpful on demand, is actually like it solves that problem because the user doesn't have to do anything. They're just delighted by, oh, nobody needed to answer that because the computer answered that because it knew the answer and it has knowledge of my entire, enterprise workspace.
Mm-hmm. It does feel like it's like the research has continued and continues to accelerate for AI. And it's like the production quality applications is naturally lagging behind. But it's like the research and the progress is going so fast. No one wants to stop to build a product because it's like, why would you build a product now? Wait 6 months and you could do, 10x more.
Right. That's exactly right. I think there's almost like a paralysis of like, should we hunker down and build a product around today's models? Or are they going to be so much better in a year that I don't even need to build this product anymore because they'll do it out of the box instead of aftermarket? And I think that's what we saw with like a lot of the thin wrapper LLM companies that were like, oh, it just, it's a writing assistant. Well, it's like, well, that got commoditized really quickly. Or, oh, it helps me ask questions of my documents. And it's like, oh, well, that's now fairly easy to do in most chat apps. So there's definitely an element of that where you kind of have this continual gap between the research and the product cycle. But we'll probably get to a point, even if they don't normalize, where the products start having a bigger impact than what we see right now.
I like that conclusion. Nick, are you satisfied?
I am.
All right. We look forward to speaking with everyone next week.
Thank you.